Tip 5. Story time. When appropriate, I like to tell a story that relates to the topic we are covering. For a greater effect, try to incorporate other classes such as math, language arts, science, or social studies into your own. If you can cross-teach with another classroom, all the better. Stories are good because they illustrate what you are teaching. They're usually pretty interesting and provide the necessary diversion that can keep a class mentally refreshed so you can keep your lesson on track. So to help illustrate how I tell stories, I'm actually going to tell you an entire lesson. I'll try to be concise, and you will hear me say a lot more and pauses because I'm not going to go ahead and clean this one up. It's far too long to put in segments. I'd rather just teach it the way I teach a class. So here goes. From the old book that I had a couple years ago, Chapter 2, Section 6, Integers in the Coordinate System. Now you see, my goal here before I start the lesson is I want to be able to tie the story, a fairly interesting story, into what we're doing today. So when I get there, where will I use this in real life, I can say, well, it's been used for the last 500 years. Okay, let's begin. So 2.6, integers in the coordinate system. Long ago, people had only what they could make with their own two hands. And picture here is obviously a caveman, and he's holding a rock, and I said like a big toothpick. I try to use a lot of humor in my lessons as well. Anyway, as time went on, people started trading other people for things they needed. Soon, people started making a living by simply buying and selling goods to people who needed them. As time went on, more money could be made by selling things to different towns. Obviously, it was hard for a man to carry all the supplies by himself. So horse and buggies came in awfully handy. But even then, there were only so much a team of horses could carry. So people found that you could carry much more on a ship than any other thing. The first ships were small and had to stay close to shore or they could be lost. Early sailing happened in the relative safety of the Mediterranean Sea, far away from the powerful waves in the ocean. As ships got larger, they were able to cross the Mediterranean without tracing around the coast. In the beginning, if a ship left the Mediterranean Sea and the coastline outside it, many ships did not return. Therefore, people in those days were sure the earth was flat. Since they believed the world was flat, the idea of it, if you traveled too far away, you would fall off the edge. However, the pursuit of money helped boost progress. You see, in those days, salt and spices were hard to come by in Europe. This is in the 1400s, when meat needed to be kept for more than a day or two, and there was no fridge to store it in. If the meat wasn't eaten in that time, it was rotten and uneatable. Turns out salt and spices can treat meat and keep it good for weeks and months. Good news, there was salt and spices to be found. Bad news, it was mostly in China and East Asia. And you can see on this map here, it's about 10,000 miles of travel over a lot of long and arduous trips through countries, bandits, a difficult thing to be sure. For instance, how much would I have to pay one of my students to hop in my car and drive to the Walgreens down the block and pick me up a gallon of milk? I bet most of them would do it just for the joy of driving my Charger, but I'd say $5 would be fine. Now what if I asked that same student to drive to Los Angeles to pick me up another gallon of milk? Obviously I'd have to pay a lot more money to have the student drive that far away. So to get spices and salt from China, the cost was very high. Soon people found it was a lot cheaper to load stuff on ships with all the stuff and sailed around Africa and southern Asia. While sailing was faster, the route was about twice as long. So that was the way it was until an Italian sailor named Christopher Columbus decided the world was not flat. He studied cartography, map making, and decided the world was round. In fact, he bet that if he traveled far enough west, he would sail into China, thus cutting the spice trip in half from having to go around Africa and India. Shorter route, more money to be made. So he loaded up the 3 ships, sailed west to discover America, and you know the rest. So at the end of the day, Christopher Columbus wanted to discover something, but mostly he wanted to discover some extra money. But instead he discovered America. Now before long, brave sailors traveled outside the Mediterranean Sea and started making maps of the world around them. They soon discovered how large the Atlantic Ocean really was. Here's a picture of the world in a larger map, big blue one here. And this might be a time when I might do a map game, but I might wait to show in a minute what I mean by that. Now, here, okay, now that you know the full Columbus story, here is how it ties in today's lesson. See, Christopher Columbus needed a way to tell where he was going. For instance, in our town, if you want to get from here to Plano, you just follow Route 34. It has signs and a road that leads right to it. But once you're about 10 miles out in the ocean, all you see is ocean, and getting lost is very easy. There's almost no way of knowing which direction you're going by just looking, and to kind of give you an explanation, you can look 360 degrees and just see the same blue line and the horizon afterwards. Now, this is all true until the invention of the sextant. With the sextant, you can tell how far north or south you are by measuring the angle versus where the sun is about noontime or so. The Earth is measured from north to south in degrees of latitude. In the center of the Earth is the equator, which is 0 degrees latitude, because it's neither north or south, so 0 is the center, and that's why it's at 0. The farther north you travel, the higher the latitude north. The northernmost point is called the North Pole, which is actually at 90 degrees. The hint to understand this, the degrees north or south can be determined by taking the line of the equator and drawing a line with a compass. So basically your equator is a flat line, and then you go up how many degrees, and you see how we're making this triangle. And so that's a good way of learning that. Now, Christopher Columbus, used this to make sure he kept a certain latitude while he sailed west, so he'd use the sextant to keep him on line. Now, later advancements let sailors know how far east or west they were. These devices measured longitude. Starting at Greenwich, England, a straight line is drawn up and down. That's called the prime meridian. How far you go west or east is your degrees in longitude. So, combined, you can tell where any place is in the world. The prime meridian, 0 degrees in longitude, and equator, 0 degrees in latitude. If you notice, our town in Sandwich, Illinois is 41 degrees north and 88 degrees west. By combining the two lines, you can find any place in the world. Now, what we're going to do is take this, but use a flat map, like one for America. Now, let me stop the instruction for a second and explain. What I would do right here, we would probably play a game, or I would point out different coordinates. I'd use a map, maybe not quite this one, but a map that's easier to see, or perhaps the world map I'd used before. And I'd go ahead and lay out some different coordinates, and what they would do is either tell me the state or the country. And when one person would get it right, I'd throw them a Jolly Rancher. And I'd do this for a few minutes, and once again, break the monotony, get them doing something else, and again, a little bit of cross-learning. Now, remember at this point, before I go on to the next slide, that we've basically told a history story. I've thrown in some economics with spices. We have some geometry. We learned some things about Christopher Columbus. So we've really bounced around here. We've done a lot of things, but now comes the real test. Can I tie this story in to the math of today? And what I'm going to do, this first slide says we are using a coordinate system to keep track of up and down and left and right. Let's start with the center of the system. It's called the origin. And I'll reference how, yes, the prime meridian line and the equator line also would form 0, 0. They are two primary lines for our coordinate system. Just like the equator and prime meridian for Earth, these two axes serve to divide up and down and left and right. We first begin with the left-right axis. This is called the x-axis. It measures left and right of the origin. So posted here is the x-axis. As you can see, it measures left and right. And the other one I have here, this is called the y-axis. It measures high or low, how high or low a point is, which is the y-axis. Now, the picture below is a guy named Chamillionaire. And the time I made this, about 5 years ago, a big song of his was Trying to Catch Me Riding Dirty. So I wrote Trying to Catch Me Riding the Axis. Kind of silly, I admit, but again, a diversion, something fun, keeps the kids entertained. It goes a long way. Next slide. This next one says, look at these. As you move to the right of the origin, your x value is increased. The line is at the x value of 3. And notice how I move 3 little bumps and put a large blue bar. I'll simply explain that it's 3 to the right of the x-axis. Then I go on to say, as you move to the left of the origin, your x values decrease. So here I have a bar going 3 to the left. The line of this x value is negative 3. Then I proceed further. The next one says, next we will measure the up and down value. This is the y value. Positive y is up and negative y is down. So the blue line has a y value of 5 and this green line has a y value of negative 2. And again, I explained up and down. And while I'm doing this, I may also reference it to longitude and latitude, showing them how just like the grids on the Earth. So to take this point in our plane, we have point A. So I make a dot right here, and I show how we use an ordered pair to show the x and y coordinate value. Next slide says, so let's count how many spaces to the right the point is. I explained that you do the x value first. As we count, it goes 1, 2, 3, 4. It is 4 to the right, so the x coordinate value is 4, and I show how the 4 is there instead of the x. And in the next slide, I show that you go 3 up. So the 3 above the origin, so the y coordinate is 3. So your ordered pair is 4, 3. And I write, no, not this kind of pair. Again, cheesy humor. You'd be surprised, though, how a little bit of a laugh, a little bit of a goof keeps people on track. So if my lesson goes more than 15 minutes, I try to throw things in there. But now comes the true payoff. Now is the you try. So they've sat there, they listened to a story, we might have had a back and forth, they might have asked questions. But now the learning begins because they've had the information, now they get to apply it. So the first you try says find the ordered pair. And I believe it's kind of hard for me to see with this little map I've made, but I think it's 6, 1. And what I'll do is I'll have them raise hands, I'll throw a Jolly Rancher to the right person, giving them time. I might walk around the room and say, hey, write this on a piece of paper and let me get your prediction. What do you think it is? And I'll walk by and say yes or no or yes, good job, almost, take a look at this again. And again, motivation is built so easily this way. They get so excited to get positive praise. And what does it cost me? A couple of ranchers and walking around the room? It's just that easy. The next one I say try again. And so we do a try again. You'll notice the dots at a different place. If we do the same procedure, I'll walk the room, I'll throw a rancher, I mix it up. Another try again. Always keep them on their toes. And I say last one. I only do about 3 or 4 of one concept. You don't have to do 50 million. You just do enough so people understand what you're doing. You've got positive feedback. They seem to know what you're talking about. You've checked for understanding. And you move on to the next thing. So after that, we get to our quadrants. And I write down that finally, we need to know that our coordinate plane is divided into 4 quadrants. And here I have quadrant 1, quadrant 2, quadrant 3, quadrant 4. And I show you how they're split apart. From there, I say, note, a point on the axis is in none of the quadrants. So actually, a dot on the line itself is not in any particular quadrant. And again, we'll do some U-tries. I ask what quadrant is the first point in. I click to the next one, a dot in the other point. Okay, no problem. And another U-try, find another dot. And finally, I do the last one, what quadrant is the point in, and I have a little finish line to once again kind of articulate they've made it, they've done well. Usually we do a little bit of homework and we'd probably play a game. And you could call it a successful lesson by my recording in 12 minutes and 50 seconds. But in reality, it would probably be more like about 25-30 minutes based on student participation, games, U-tries, and whatnot. And there you go. On to the next tip.